Have you ever wondered about the famous Velociraptor, a fierce and agile dinosaur that roamed the Earth millions of years ago? In this video, we will dive deep into the intriguing world of the Velociraptor, a carnivorous dromaeosaur theropod with a fascinating history, from its initial portrayal as a large scaly lizard to its evolution into a possible bird-like creature. This predator was part of a diverse and dynamic family of running lizards. So get ready to uncover the secrets of the Velociraptor and explore the world of dromaeosaurs in this exciting adventure. Dromaeosaurs were covered in feathers, resembling giant birds, exhibiting bird-like behavior. Fossilized teeth suggests that they inhabited Australia, in addition to other regions across the globe. The subfamily of Velociraptorinae taxonomy is heavily debated, with some including Deinonychus, while others exclude it. Velociraptor was a small genus growing up to 15 kilograms or 33 pounds, with two species, Mongoliensis and Osmolsky. Its size has been compared to that of a turkey, but a more accurate comparison would be the Andean condor, the largest bird of prey in terms of weight only. Velociraptors were only 6.8 or 2 meters long, but were relatively tall at 20 inches or half a meter. Even though they were relatively small, their appearance with feathers made them look larger. Their reputation for being deadly was justified as their main weapon was their teeth, which were serrated and could leave massive wounds on prey. The puncture and pull feeding method was used where they would chomp down on their prey and pull their teeth through flesh. Despite their small size, they could take down much larger prey, and their teeth were able to handle struggles without getting damaged. While the teeth of velociraptors were used for killing prey, their hand claws played a vital role in gripping the prey and getting it into the predator's mouth. The idea of knives being attached to their hands is far-fetched, and their claws were more like those of big cats, primarily used for hunting and fighting. The dromaeosaur had 3 claws on each hand, resembling modern bird wings, and the wrist bones forced their palms to face inward, not downward. Similarly, their toe claws were not meant for disemboweling prey, but for gripping. Velociraptor, a type of dromaeosaur, had a small dew claw as its first digit, but unlike theropods, it walked on only its 3rd and 4th digits. Its 2nd digit was a famous killing claw that could grow over 2.5 inches long. This sickle-shaped claw was used for tearing into or restraining struggling prey, which was a technique the group likely used to dominate smaller animals. The feathers on their arms helped them stay balanced while they flapped their wings, and while their teeth were their best weapon, their claws were instrumental in catching and finishing prey. A recent study on the arc of dromaeosaurid claws has shown that most dromaeosaurs were capable of climbing trees and perching like modern birds. The Velociraptor claw, which possessed an arc measurement of 127 degrees, fell within the range of claws used for perching and trunk climbing. This empirical evidence suggests that velociraptors and other dromaeosaurids were able to climb trees, an advantageous trait that may have aided in hunting and eating prey in peace. The discovery of the fighting dinosaur specimen, which preserves a velociraptor and protoceratops in combat, provides direct evidence of predatory behavior and sheds light on the diet of these deadly yet tiny dinosaurs. The scleral rings of velociraptors, protoceratops, and modern birds and reptiles suggest that velociraptors may have been nocturnal, while protoceratops may have been active during short intervals throughout the day. The fighting dinosaur specimen shows the velociraptor using its sickle claws to puncture the throat of its prey, while the protoceratops clamps on its attacker's forelimb. However, this is an unusual fossil and not evidence that foot clawing was their main attack strategy. Paleontologist David Hahn believes that velociraptors primarily ate small creatures, including reptiles, amphibians, insects, small dinosaurs, and mammals, and occasionally hunted larger game. The intelligence of velociraptors has been a topic of debate. While their brain-to-body size ratio suggests that they were relatively clever compared to other reptiles and dinosaurs, they cannot be compared to the intelligence of modern-day animals like crows. Evidence of social behavior among closely related dromaeosaurids has been found, but none specific to the velociraptor itself. The dinosaur depicted in Jurassic Park is based on Deinonychus, but they use the name Velociraptor. A discovery of shed teeth on carcass suggests that velociraptors may have scavenged for food, and that Protoceratops were a significant part of their diet. In 2012, Hone published a paper on Velociraptor specimen with dark pterosaur bone in its gut, indicating scavengering behavior. Velociraptor was warm-blooded to some extent, as they required significant energy for hunting. Its feathered covering served as insulation, similar to modern warm-blooded animals. However, growth rates of dromaeosaurids and early birds suggest a moderate metabolism. The kiwi, a flightless bird with dromaeosaurid-like anatomy and feather type, serves as a model for primitive birds and dromaeosaurid metabolism. Feathers have been found on dromaeosaurids, indicating that they were fully feathered and had developed wings. In 2007, quill knobs were discovered on the forearm of Velociraptor found in Mongolia, proving that the dinosaur did indeed have feathers. Paleontologists had long suspected that velociraptors bore feathers, as their ancestors were feathered and capable of flight. While a lack of quill knobs does not necessarily mean a dinosaur did not have feathers, their presence on velociraptors indicates that it did. This finding supports the idea that there is essentially no difference between birds and their dinosaur ancestors, such as velociraptors, as both possess wishbones, brooded their nests, and are covered in feathers. Not all prehistoric birds had quill knobs, which do not indicate the presence of feathers. For instance, flamingos lack these knobs, whereas the modern-style wing feathers of velociraptors with arachis and veins formed by barbs confirm their presence. In this species, 6 preserved knobs suggest the presence of 14 secondaries, compared to 12 in Archaeopteryx, 18 in Microraptor, and 10 in Rahonavis. Feathers protect and insulate animals, but they may also serve for displays, nest covering, and wing-assisted incline running, as recently suggested. Wing-assisted incline running is seen in a wide array of modern birds, such as turkeys and other galliforms to climb trees to stop. Many dromaeosaurs and other flightless birds may have climbed trees or other inclined surfaces by running on their claws and flapping their wings for an extra boost. This theory is often cited in the origins of flight and birds. The feathers of the velociraptor served various purposes, just like those of modern birds. All discovered specimens of the Velociraptor mongoliensis have been found in the Djokgada Formation of Mongolia's Omnigov province, while others were found in the Barun Goyet Formation. These formations date back to the companion stage of the late Cretaceous epoch, between 83 and 70 million years ago. Velociraptor fossils were found in arid environments with dunes and intermittent streams. Many fossils show that some specimens were buried alive during sandstorms, and the velociraptors disappeared from the fossil record 70 million years ago. In conclusion, Velociraptor is a fascinating and deadly dinosaur that has captured the imagination of people for generations. From its evolution into a bird-like creature to its possible nocturnal habits, velociraptors were a diverse and dynamic group of running lizards. With their serrated teeth, sickle-shaped claws, and feathered arms, they were formidable predators capable of taking down much larger prey. While much of their behavior remains a mystery, the discovery of fossils and shed teeth has shed light on their diet and scavenging habits. Velociraptors and other dromaeosaurs were truly a remarkable group of creatures, and we can only continue to learn more about them as we uncover more fossils and research their behavior. And that's a wrap. Remember to like, share, and subscribe to our channel for more fascinating videos like this one. Until next time, keep exploring and never stop learning.